Let's talk about something that's really shaking things up in the cloud-native world, Micronaut. If you've been building microservices, or you're just on the hunt for a way to make your apps faster and more efficient, well, you're going to want to pay attention to this.
So let me ask you a question. Are your cloud apps fast enough? I mean, really fast enough for today's world? We live in this instant-on culture, right? Everything needs to scale up like yesterday. Speed isn't just a nice-to-have anymore, it's an absolute must. And if you've ever sat there waiting for an app to start up, you know exactly the pain I'm talking about.
And yeah, that's the heart of the cloud-native challenge, isn't it? When you're dealing with things like microservices or serverless functions, they have to start up almost instantly. And they need to sip memory, not chug it. Because every single millisecond, every single megabyte, it all adds up. It affects your user's experience, and it definitely affects your cloud build. The thing is, a lot of the frameworks we've been using for years, they just weren't built for this new reality. They're kind of like these big, powerful engines from the muscle car era. They get the job done, sure, but they're heavy. They take a while to warm up. And in the cloud, where everything needs to be nimble and quick, that's a huge bottleneck.
So, this is where Micronaut enters the scene. And look, this isn't just another framework with a new logo. It's a fundamental rethink of how a framework should even work. It was literally designed from day one to tackle these exact problems we see in modern cloud-native development. Okay, so what is it really? Well, at its core, Micronaut is a modern framework that runs on the JVM. It's for building those modular, easy-to-test microservices and serverless apps we've been talking about. And if you're coming from something like Spring Boot, you'll feel pretty comfortable. But you're going to notice a huge difference right away. And it all comes down to one thing: performance.
First off, fast startup times. And I don't just mean a little bit faster. We're talking about applications that feel like they launch instantly. For a serverless function that needs to spin up from cold, or a set of microservices that has to scale out like crazy, that is an absolute game changer.
Then there's the memory usage. It has a super low memory footprint. So what does that mean for you? Well, it means you can pack more services onto the same machine, which, you guessed it, translates directly into lower costs on your cloud bill. It's all about doing way more with way less.
And if that wasn't enough, it's also cloud-friendly right out of the box. You see, Micronaut doesn't just run in the cloud, it was built for the cloud. You get top-notch support for stuff like AWS Lambda and Kubernetes baked right in. No extra hoops to jump through.
So you're probably wondering, how in the world does it do all this? What's the secret sauce? Well, it all comes down to one core idea, a kind of secret weapon, you could say. It's called the ahead-of-time advantage. And believe me, this one architectural choice changes everything. Let's dig into what that actually means.
Okay, this slide right here is the key. Traditional frameworks, they do a lot of their work at runtime. When your app starts up, they use this thing called reflection to scan all your code and figure out how to connect all the pieces. It's flexible, but it's slow, and it eats up a ton of memory. Micronaut? It just throws that whole idea out the window. Instead, it does all that thinking, all that heavy lifting at compile time, before your app even runs. That means no reflection at runtime, no slow analysis, just pure speed. And that's how you get those near-instant startups and that tiny memory footprint.
And that whole process is called ahead-of-time compilation, or AOT for short. Here's a good way to think about it. Imagine you're building some IKEA furniture. The traditional way is like opening the box and trying to figure out the instructions right there in your living room. The Micronaut way is like having the entire piece of furniture pre-assembled at the factory. All the hard work is already done. When it gets to you, it's just ready to go. By the time your application starts, it's not figuring anything out. It already knows exactly what it needs to do.
All right, so that's the theory, but what does this actually look like when you're writing code? Let's take a peek at a real example and see how simple it all comes together.
Just look at this. It's so clean, right? Super simple, very easy to read. In just a handful of lines, you've got a fully working API endpoint. But notice what's not there. No crazy XML files, no giant configuration classes. All that ahead-of-time magic we talked about, it's all happening behind the scenes so you don't even have to think about it.
So, when should you reach for Micronaut? Well, it's a slam dunk for building fast, efficient microservices. It's tailor-made for serverless functions on AWS Lambda or other cloud platforms. If you're building lightweight APIs that need to be super high performance, it's perfect. Honestly, if you're working on the JVM and startup speed or memory usage matter to you at all, you have to check out Micronaut.
Okay, let's bring it all home. What's the one big takeaway here? What's the core idea you should really remember from all this?
It really all boils down to this. Micronaut's promise is performance by design. It gets rid of that slow runtime reflection and does all the work at compile time instead. And the result? You get lightning-fast startups and a crazy low memory footprint. It's built for the cloud from the ground up, and it lets you write simple, clean, modular code. It's just efficient.
And that leaves us with a really interesting question, doesn't it? Micronaut is betting big on this fundamental shift, moving all that hard work from runtime to compile time. So it makes you wonder, is this the future? Is this a ahead-of-time approach where all high-performance frameworks are headed? I think it just might be.